A concentration cell is based on the Nernst equation, which we have to recall as the cell potential developed is not just made up of the standard cell potential, but also includes another component which takes into account the chemical activity. So Q is going to be the reaction quotient, where we know Q is the concentration of your product raised to a quotient and then divided by the reactant B. In the concentration cell, E naught is going to be 0. E naught is 0 because we are going to use the same electrode as both the cathode and the anode. And so we know that E naught should be equal to the reduction potential at the right hand side minus the reduction potential at the left hand side. So both potentials will be the same. So let's say, for example, if we were using lead to lead 2 plus, then both reactions between lead 4 plus going to lead 2 plus will be 1.67 at the reduction half and then minus 1.67, giving us 0. Based on this, we see that there's not going to be any potential based on the potential difference of the electrodes, but there's going to be a potential developed in the cell as a result of the concentrations. In this particular cell, you notice that we are going to have the same electrolyte. So let's say if it was lead to lead 2 plus, you are going to have also at the other side the reduction side, you are going to have the same thing. And so the reaction quotient, which should be equal to the concentration of your product, here for the general reaction, we would have lead 2 plus lead going into lead 2 plus lead. Q should be equal to concentration of your product, which is lead 2 plus times lead divided by your reactant, which is lead 2 plus lead. The quotients are the same, so we are going to leave it as 1. This is all going to be raised to the power 1. Now the activity of pure solids and liquids should be equal to 1. So your pure solid of lead will have an activity of 1 because they are pure, they are not fractions. You see that if the concentrations are the same, given that the stoichiometry itself are the same, okay, if the concentrations are also the same, then this will cancel out to give us 1. The numerator and the denominator will cancel out to give us 1. And so the overall reaction will be equal to 0 because E will become 0 minus RT ln 1, and ln 1 goes to 0. So this whole thing goes to 0 and the cell is not going to do work. So for concentration cell to do work, there should be a concentration gradient between the two cells. So Q, for the system to do work, then Q should have a lower concentration of the anodic side, let's say 0.01 molar, compared to the cathodic side, because that's the reactant side. So that would be 0.1 molar. And then let's find Q. Now we already know that when you take ln of a number less than 1, you get a negative value. And so E will become equal to 0 minus RT over NF times ln Q, which is a negative value, giving us a positive cell potential, and then work is done. Let's imagine that in Q we have the concentration of the anodic side to be higher. So if the concentration of the anodic side is, let's say, 0.1 and the cathodic side is 0.01, then Q will be equal to, and ln of a number greater than 1 will give us a positive value, which means that Q will now be equal to E will now be equal to 0 minus RT, which we can simplify to give us 0.0591 divided by 2 being lead, and then this portion becomes a positive value, meaning that the EMF will be negative, which means that the system cannot work, but the surrounding will work on the system. So this will become non-spontaneous. Okay. Now that we understand, so the anodic side should be lower in concentration than the cathodic side, and we are able to explain that because the electrolyte at the product side comes from the anode. So that was explained in the previous video. Now that we've understood that, let's move further to now understand the pH as a concentration cell. The pH meter is made up of the hydrogen electrode, where H2 is going to 2H plus 2 electrons at both sides. So this will be the oxidation half, and this is the reduction half, whereby 2H plus 2 electrons react to form H2. So this is what is going on in the electrochemical cell, and we can do the notation to be platinum being the reaction site, the inactive electrode, and then we have hydrogen gas H plus H2 gas platinum. So you see that in terms of the EMF, of standard EMF, E naught will be equal to 0, because platinum minus platinum will give us 0. So the only thing we can do now is to base it off the concentration of the electrolyte, hydrogen chloride. So we always have a reference electrode for the pH meter, which has a known concentration, and then we dip the other electrode into our solution containing the acid or the base. So that contains what's the unknown. E is equal to E naught minus nRT over NF, then Q, and E naught for the concentration cell equals 0, then E potential difference is equal to minus 0.0591 over N log Q, and pH is equal to minus log Q. which means N also is equal to 1, and E will be equal to minus 0.0591. pH of the anode minus pH of the cathode.